Okay, there's a process for turning binomials that have differences, or should I say negatives, back into binomials times binomials. And here's the rule. So if you have a squared minus a b squared, and you want to return this back to a binomial times binomial, which is this binomial times binomial, you take the square root of the first term, which is a squared, and you get an answer. You take the square root of the second term right here, which is a b squared, you get another answer. Take those two answers there, put them here, plus b, and then take the same two answers and say minus the b. Okay. Example of that would be something like a 9x squared minus 16. So you would take the square root of the 9x squared, which gives you a 3 times x, and the square root of the 16, which gives you the 4, and you take those two answers there. That's your a, that's your b, and you'll have a plus b, so it'll be a 3x plus the 4, and then you have a minus b, which will be the 3x minus the 4. All right, so let's take a look at this rule again. We're going to put this rule to work, which is turning the difference of two squares into two conjugates. These are called conjugates. If I can spell that word. Okay, so difference of two squares. Difference of two squares. All right. So here we have difference of two squares. We're going to take the square root of the 16x squared and the square root of the 25. The square root of 16 is 4. The square root of x squared is x. And the square root of 25 is 5. Okay. So now we're going to take this a and this b and say 4x plus the 5, and then 4x minus the 5. All right, next we're going to take the square root of the 121 and the x squared, and the square root of the 225. The square root of the 121 is 11, and the square root of x squared is x, and the square root of 225 is 15. So that's your a and that's your b. And so you're going to put your a plus b, which is going to be 11x plus 15. And then you're going to put your a minus b, which is 11x minus 15. Okay. All right, next. We have 81x to the fourth power minus 1. So we're going to take the square root of the 81x to the fourth and the square root of 1. The square root of the 81 is going to be a 9. And the square root of the x to the fourth is going to be x to the second. Now the reason why we know this is right is because 9 times 9 goes back to 81, and x to the second times x to the second goes back to x to the fourth. The square root of 1 is 1. The reason why we know this is because 1 times 1 goes back to 1. All right, let's put our a and b in and make our conjugates. This will be 9x squared plus 1, and this will be 9x squared minus 1. Okay. All right, 16. We're going to take the square root of the 16x to the 6th power and the square root of the 169. Now the square root of 16 is 4. The square root of x to the 6th power is x to the 3rd. And the square root of 169 is 13. So that's your a and your b. So we're going to put those in. So this will be a 4x cubed plus 13. And over here will be a 4x cubed minus 13.